this is called the derivative and the equation of the tangent line. Am I in anyone's way here? Good. I stole this picture from the internet. Okay, you can get anything on the internet nowadays. But so the secant line approximates the rate of change of a function at some particular point. So, for instance, if this is the point, this is the point C right here, and both actually, in this case, this is the point C, and this is X. Okay, and what this says is I can approximate the rate of change of this curve by doing this thing called the secant line. Now, the secant line, all lines have an input length. This should actually go all the way through. Okay, so and the slope of the secant line is f of x, which is the y value at this point, minus f of c, which is the y value at this point, over x minus c, which is the distance from here to here. You understand that? Okay?
No.
You don't understand that?
No.
So if I were to draw a little triangle, right? This is called the slope. Well, that's not very good. But the slope of that line right there, right, is the rate of change of that, is the rate of change between this point and this point, or the average rate of change. Yes? You understand that concept? Okay? And that's called the secant line. If I drew a point here, what I'm trying to do is find the rate of change exactly at point C. Okay? So what I do to find the actual rate of change, which is the slope of the tangent line, because this instead of going through the curve at 2 points, as I move this point x closer and closer and closer to that point, do you see that the rate of change gets closer and closer and closer to the exact value of the rate of change? You understand that concept? As this point slides down, right, then I'm getting closer and closer to the actual slope at that point. Yes? Moving on. So as I slide this point down, right, you get closer and closer and closer to the exact rate of change at that point. In other words, you can find the instantaneous rate of change, which is the slope of the tangent line indicated by this, as the limit as x gets closer and closer and closer to c of f of x minus f of c over x minus c. And that's called the derivative. Okay? And I think I talked about this, didn't I? Talked about this a little bit.
What is h in that equation?
What is h? I'm going to talk about that in a minute too. Okay? And the equation of the tangent line is y minus y. So if I want to find the equation of this line, right? This is y minus y1 over the slope times x minus x1, in which case this is the point c comma f of c, and this is some other point, and this is x comma y, which are just variables. Okay? I'll do one of these, you'll see what I mean. In this equation, the way they define that, I guess I have to draw a picture. Okay? So say it's really the same idea, but it's more of a general formula. I could try to draw that curve. So let me try to draw this, where it's really dark in here. Okay? So say I have this as one point over here, okay, and this at another point, and I want to see. I'm going to call this point x, okay, and I'm going to call this point the distance. If I were to draw a little triangle right here, okay, and this distance is h, okay, then this point would be what? What would be the x coordinate of this point? If this is x and this is x, this would be x plus h, right?
So how do you determine which one's C and which one's X though? Like why is that first one X and second
Because in
one X?
this one, C is a specific point, okay? In this case, x can be any point on that curve,
Oh,
okay?
I get it.
So this is kind of giving you a formula for finding the equation of the tangent line, or the slope of the tangent line at any point on the curve. After I get done with this, then I can plug in a value and I can figure out the slope of the tangent line at a specific point. Okay? So this is x plus h, comma, f of x plus h, right? Then this is, do you understand that? Okay, that's the point, there should be another parentheses there. Then this is just the point x, comma, f of x, yes? And that's where this formula comes from. It's f of x plus h minus f of x. And the distance from here to here is x plus h minus x, which is just h, okay? And if I take the limit of that as h gets smaller and smaller and smaller, right, I will get the exact value of the slope at any specific point, okay? It's kind of a little bit, so this formula isn't in your book, but I think it's easier to do some of these problems to this, okay? So the equation of the tangent line. So let's do this problem right here. You ready?
Okay.
You're ready. Okay, Daniel's ready. Here we go. Partial. Here we go. So let's see if I can remember. Find the equation of the tangent line of the graph of the equation f of x equals 2x squared minus 2 at the point where x equals 2, then verify with your calculator. So the first thing that you're going to do, this is the one where you use the limit as x goes to c. So this is going to be what? 2, okay? Of f of x, which is 2x squared minus 2, minus f of c, and c is what? 2, okay? Over x minus 2. So you have to do a little bit of algebra here.
F of 2. Would you do the x minus 6?
Thank you. Where did I get what? It's f of x minus f of c. C in this case is 2. This is like c equals 2. Okay? So you want to know when x equals 2. That they mean that the value that you're finding the derivative at is 2. Okay? So you plug this in, and you get that this is equal to the limit as x goes to 2. Didn't we already do this in the previous lesson? A little bit, or got close to it. 2x squared, and Daniel tells us when I plug 2 into this equation, right, I get 2 squared, which is 4 times 2, which is 8 minus 2, which is 6, over x minus 2. And then I'm going to keep going. That's equal to the limit, and you really have to write limit every time, otherwise it really doesn't make that sense. 2x squared, I'm going to go step by step, over x minus 2. And then, if I try to plug in 2 in here, I get undefined, right, in the denominator. So I keep working with this so that I can factor something out. I'm going to pull out a 2x squared minus 4, which I should have a limit in front. See, I always do that too. And that's equal to the limit as x goes to 2 of, what is that top factor to? X plus 2 times x minus 2. And then I can cancel out the, x minus 2. And then I can cancel out those x minus 2. And what I'm left with is the limit as x goes to 2 of 2 times of, if I distribute that, I get 2x plus 4. And now I can take this and plug it in, and I get 8. Okay? So what does that mean? That means if I were to graph this parabola, which I know is a pretty steep parabola that goes through -2, it means at the point 2, comma, -6, which would, I guess, be down here somewhere, right? At that point, the slope of the line going through that point is what? -8. So the slope of that line is -8. Okay? Sorry, is positive. Sorry. Okay? You understand that? And it says verify with your calculator. We're not done yet, because you want to find, it asks you to find the equation of the tangent line. So all I have to do, I know that this is the point 2, comma, -6, right? I get the -6 from taking that 2 and plugging it into my original equation, okay? So that which case the slope is the derivative, right? And the point is the point where you want to figure out, you want to find the equation of that line. So in this case, that point is y minus minus 6 gives you plus 6 equals m, which is 8, times x minus 2. And that is the equation of the tangent line at that point. If you want to rewrite that with the y-intercept, you know, in standard form, which you don't have to, this is pretty good, but that's equal to y equals 8x, let's see, minus 16, minus 6 more makes minus 22, right? So that would be the equation of that tangent line. And if I plug that into my calculator, I would, what? You don't think that seems right?
Isn't y1 positive 6, so shouldn't it be y minus 6?
No, he's right.
Y is negative 6?
Yeah, because it's 2 negative 6.
Should I get,
It's minus 3.
is it 2 minus 6? Oh, I did it wrong. Sorry. Stop the video. Daniel's right. This should be, I thought that was kind of weird. So he's right. It goes through 2 comma 6. Okay? So not, the slope is still the same, but it's going like this, right? Yes? Good. Sorry. So it's y minus 6 equals 8 times x minus 2, which that's why I should rehearse before I try it. So this gives you y 8x minus 16 plus 6, which gives you 8x minus 10, right? Thank you. Okay? So I screwed up a little bit, but not that bad, right?
Where'd you get negative 6?
We're like at the negative, it's not negative 6, it's positive 6. F of 2, right? F of 2 is positive 6. And I could have gotten that's what this equation means right here, right? Y minus f of c is, so I'm plugging in 2 into the equation, so that's 6, right? S, slope of the tangent line, which is the derivative, x minus 2. And then verify with your calculator. I'm not going to do that right now. Good? So now, you're going to really like this part. Good? So now I'm going to use this formula, okay? Because this formula is kind of cool because you could use it to find the derivative at any point on a function. And some of you may know the shortcut. Some of you know the shortcut already? Antoine explained it to you. But he doesn't really understand it. He knows how to do it, but okay. It doesn't matter. What difference does that make? Okay. So using limits. So this says using limits, not using the shortcut that Antoine told you. Okay. Find the equation of the derivative. Okay. So what that equation is going to give you, this is going to make a parabola, right? It's going to make a parabola. It's going to give you the slope of the curve at any point, which can be very, very useful. Do you have a question?
I think I was gone when we were talking about derivatives.
What is the derivative? Keep recording. So I'm going to take the limit as h goes to 0. Watch this process. I made a mistake this morning when I was doing it myself. Of f of x plus h. So I'm going to go 3. And in here, I'm going to plug in x plus h in for x squared. Okay? Minus 2 times, I'm plugging in x plus h in there. Okay? That's f of x plus h. Minus f of x, which is just this. 3x squared minus 2x over h. Okay? Now, don't complain because I know that Mrs. Hine makes you do this, and next year you're going to have to do this, and this is a headache for a lot of kids, and it's good to practice it now because you're going to have to do it next year as well. So does the Calc AB teachers, the BC teachers, and the AB teacher. So the best way to do this is just to distribute everything out. Okay, so I'm going to get the limit as h goes to 0 of when I'm going to leave the 3 outside, and when I FOIL this, I get x squared plus 2xh plus h squared. Everyone sees what I did? Well, that minus, what do I get here? 2x minus, no, don't forget the minus sign, minus 2h. Keep your sign straight. Minus, up. That's wrong too because it's like this, right? It's minus f of x. So minus 3x squared plus 2x over h. This is fun. Watch. Okay? So now, look, this is equal to the limit. There should be little equal signs as we go. Equal, equal. Okay? This is equal to the limit. Now, see how I have a 3x squared here and a minus 3x squared there? What can I do with those two things? I'm gonna, hello? I could just, should I just distribute everything out again?
Yeah.
Yeah, I better do this. 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus 3x squared plus 2x over h.
You can cancel out
Now.
the two x's as well.
Okay, good. So this goes away, right? Where's minus 2x? It is minus 2x,
Right, so minus
but this is a
2x.
plus 2x, right?
So
Because
this
it's
will go
minus
away.
minus. So this goes away as well. See that? Everyone with me? Okay. What else can I make go away? What else could I cross out? See how there's an, now that I've canceled out those x's, I would rewrite this again, but I'm too lazy. I could divide an h into everything, because if I plug in h in here, I get divided by 0, which is no good. So I could cancel out this h with that h, and this turns into a 1h, and this goes away. Everyone with me? What I did? Because I can't, because these terms are gone, right? This term is gone, this term is gone, this term is gone, this term is gone. So now I can cancel out h. So now what I get is the limit as h goes to 0 of 6x minus plus 3h minus 2. Okay? Now I can evaluate my limit, and I'm going to plug that in there. Okay? And that's equal to 6x minus 2. So this is the equation of the tangent, or sorry, not the equation of the tangent. That's the equation of the derivative, which they call f prime of x, which can also be called dy dx, okay, which is also the instantaneous rate of change. So you say, big deal. What's so great about that? Okay, what's cool about that, let me just show you, is, can I go back up? I can go back up. Look, what's cool about that is here's my function, right? 3x squared minus 2x, okay? Here's my function. 3x squared minus 2x, what does that look like? 3x, I don't know, it's a parabola. It's got a 0x, where does it go? 3x times x minus 2. It has a 0 here, and it has a 0 here. So it's a parabola that looks kind of like this, right? Through those 2 points, trying to get through those. Okay? What this gives you the slope at any point on that parabola. So if I want to know, for instance, what is the slope right here? What would you expect the slope to be right there?
X.
What would you expect the slope to be right there?
Oh, nothing.
0, right? And if I plug it, I happen to know that the intercepts of this are 2 and 0. What's halfway between 2 and 0? 1. Uh-oh. Maybe it isn't the intercepts. 2 and 0. You would expect the slope right there. Maybe I didn't graph my problem. 3x, 3. Oh, I messed up. Okay. But you get a parabola, but this will tell you the slope at any point. So if I plug in 0 in here, what do I get out? negative
it would
2.
be
I'm
negative
sorry.
2.
Zero is not.
Sorry, I get out negative 2. So the slope at 0 is negative 2. Okay? What's the slope at 1? 4, right? So as I get to, so it obviously turns somewhere in between there, right? So the slope at 1, if I go to 1, is going to be 4. So probably it's a parabola that looks more like this, okay? So the slope at 1 is 4. What's the slope at 2? 6 times 2 is 12 minus 2 is 10, right? So the slope changes as you move along that parabola. You understand that? What?
At what point do you just call it infinity?
It never goes to infinity because it's a parabola and it never goes, it doesn't get infinitely steep. These are slopes because this is the derivative and the derivative gives you the slope at any point, okay? So, I don't think I'm going to do the next one because that would be too much, wouldn't it? Yeah. But, so in this one, let me just tell you what you're doing, okay? It says the volume of, I'm not going to do the whole problem. This one's in your book. The volume of a cone with the radius r and a height of 6 is given by the formula v equals 2 pi r squared. The height of the cone remains constant, but the radius is changing. Find the instantaneous rate of change when the volume is 3. So this is the volume of a cone, not of any cone, a volume of a cone whose height is 6 inches, okay? And so, in other words, it's a cone. Oh, watch this. Where's my gallery? See this thing? No, where's that thing? Gallery. Watch. Watch. Watch me go. I want to show you something cool. Uh-oh. Content. It's going. There. Math. Geometry. 3D figures. Shh. Thinking. What? Where'd that cone go? There, it went up?
You're gonna have to format it.
Yeah, you go up the right. Come down. Anyway, go down here. There. No, I want to bring it down more, right? So here's a cone, right? And how do I close all this stuff? Can I get?
Actually, just right here, that's only half of
It's only half of
it.
a cone?
Yeah. You learned in economics that the full cone is both sides.
Oh, let's just get icky right on. Anyway, well, this is a whole cone in my book, and so this is a cone whose radius is, so this here, or height is 6, and the radius is r, and this thing, it's like it's always 6 inches high, but it's expanding, and that formula comes out of, if you remember from geometry, 1/3 pi r squared h. Remember that? That's the volume of a cone. And if I plug in 6 in here, okay, I get out 6 divided by 3, which is what? 2 pi r squared, right? And so what you want to do with this one, you want to find the limit as, as r goes to 3, because you're trying to find the volume of the cone when the radius is 3 of 2 pi r squared minus 2 pi times 3, which is 18 pi over r minus 3. This is what? 18 pi, because the question says you want to find how fast is the volume when this is 3. So that comes out to be 18 pi. All right? All right. I'm not done yet. What? You want me to finish? You don't understand what?
I don't understand this.
Well, Okay, so the question says, if I go back, I'm going to lose it. Maybe not. The question won't go down. I think I could go back after.
Do you want us to just
Okay.
repeat the question?
No, I can find it. The question says, the volume of a cone with a radius r and a height 6 is given by the formula 2 pi r squared. It's already where that formula is. So the height of the cone remains constant, but the radius is changing. Find the instantaneous rate of change when the radius is 3. So what I'm finding is the limit as the radius goes to 3 of the volume. Okay? So it's v of r, the variables are changing, minus v of 3 over r minus 3. Do you understand that? It's the volume with respect to the radius minus the volume at 3 over the radius minus 3. So I want to figure out how fast is the volume changing. Because if that radius, so say I have this cone, right? What's going to happen to the volume if this thing is getting bigger? The bottom is getting bigger. The volume is going to get bigger, right? But depending on how big that thing is, the volume is getting bigger at differing rates. Okay, so that's kind of what they're trying to figure out. And then you just plug into this. Am I still recording? I am. So how do I go back to what I wrote? Go back. So I just take the this, okay, and I can factor. I said I wasn't going to do the problem, but I guess I will. This is the limit as r goes to 3 of, I can factor out a 2 pi out of both of these. 2 pi times r squared minus 9 over r minus 3. And that top factors to 2 pi times r plus 3, r minus 3, right? That should be r minus 3. And on the bottom I have r minus 3. And then those go away. And now I can plug in my 3 into here, okay? And I get 2 pi times 6. What's 2 pi times 6? 12 pi. So that's the rate at which the volume is changing. So if that's in inches, this would be in inches cubed per